So let's take a look at the conic sections. ACT goes up to conic sections. I'm going to give you just enough knowledge to pass the ACT test, and we're going to dive more in depth the last chapter of our class, but let's just take a look at these right here. So a conic section is one of the shapes formed by slicing a cone. Okay, so you take a cone or two cones right there. So if you take a nice horizontal plane right there, you get a circle. If you slice the cone on an angle, then you get more of an oval or an ellipse. If you slice right here with a plane and just get one half of it going forever, then that's the parabola. And if you go nice and vertical here slicing, then you'll get this cone and you'll also get this cone, which means you get the hyperbola. Okay, that's what those look like, and that's where it comes from. Okay, so let's study the first one. The standard form of the equation looks like this: x minus h squared, and then y minus k squared. And don't forget to change. So you have to know that the center of the circle is h comma k, change. And the other important thing to know is that the radius of the circle is r. So you square root that r. Okay, and then there's a circle. Now the hardest part about these is usually the completing of the square part. So let's take a look at these, and the first thing I'm going to do is rearrange and put all the x's together. So x squared minus 6x, and then I'm going to leave some space for that. Then let's put the y's in descending order. Y squared minus 10y, leave some space for that. And then over on the right-hand side, I'm going to move the constant 25, making him negative. Okay. Now to complete the square, there's a couple things that need to happen. First, your leading coefficient must be 1, which it is. Then you half and square. Half of negative 6 is 3, squared is plus 9. If you add it to the left, then you add it to the right. I know sometimes we add it and then compensate it by subtracting, but that's because we were on the same side. If you're on other sides of the equal sign, then you do to the left as you do to the right. Half of 10 squared is 25, so I will add 25 to the left as well as the right. Now it's time to factor, so we have x minus 3 quantity squared. These are always going to be perfect square trinomials because that's exactly how you made it. Y minus 5 quantity squared, and the constant on the right, cancel, is just going to be a 9. So hopefully you can complete the square. Looking at something like this, it just might be a question of what's the center. So you have to know that the center is, change, 3 comma 5. It's the opposite of those things. And you have to know that the radius of such circle is 3, square root of 9. Okay, knowing that might be enough to either answer the question or look at a bunch of pictures. Of course, you don't graph on ACT, but you'd find the picture that was 1, 2, 3 to the right, 1, 2, 3, 4, 5. Oh my goodness, this is a terrible looking circle. The radius is 3, so let's just scratch this. And we're going to go down 3, 1, 2, 3. We're going to go left 3, up 3, right to here's the circle. This is a much better looking circle with a radius of 3. Okay, let's take a look at ellipse. The ellipse is in the circle family, very much related. The only difference is the ellipse is not a perfect circle. So what it has, okay, is the x and the y. That's the numerator part. But then right down here is a squared and b squared. And what I like to usually call those instead of a and b is r sub x squared. And the radius for y I call r sub y squared. That's what I like to call it, and I don't have to remember what goes with what. So when you're looking at an ellipse, you have the center. From the center to the right and from the center to the left, that is r sub x. That's the radius in the x direction. But then going up and down from the center, you go up so far, that's r sub y. And then you go down, r sub y. So an ellipse is just like a circle, except he has different radii for the x and for the y axes. Okay? So take a look at this right here. And the important thing to remember is that they have a plus sign, just like circle, and you have to make a 1 on the right-hand side. Okay, you have to have a 1 over here. All right, so let's get this equation in standard form. It's already been factored and stuff, except I don't have a 1. So what I need to do here is subtract 6 from both sides. Perfect. Now you got the 1. So x plus 3 squared over 36. Then it's y minus 2 squared over 4, and now you have a 1. If that number was anything else, I would just simply divide all terms by that number and make a 1. But they gave it to us pretty nice here. So a couple of things you have to be able to tell me. Okay, first of all, what shape is this? Since I see a plus sign with a 1, and these numbers are different, this is going to be ellipse. How about the center of the ellipse? Can you tell me the center? Negative 3 comma 2. Good. Negative 3 comma 2. How about the radius? Now I have to be very specific here because there's a radius for x and there's a radius for y. R sub x is going to be 6 and R sub y is 2. So those radii numbers there are squared. Okay, to graph something like this, you would have to pick the graph, of course, multiple choice. Negative 3, 1, 2, 3, comma 2. So here's the center of the ellipse, and now we have to use those radii numbers. R sub x is 6, so let's go 6, left and right. 1, 2, 3, 4, 5, 6. So the edge of the ellipse would be right here. And 1, 2, 3, 4, 5, 6. Here's the right-hand edge of the ellipse. Then we're going to go up and down R sub y 2. So you go down 2, brushing the x-axis, up 2, right there. And so the ellipse is pretty wide. It's a skinny ellipse. There you go. Okay. A lot of times, just being able to tell the shape by looking at the equation is enough to get the job done for ACT. Remember, he's got the plus just like circle. He's got 2 different numbers. And you always have to have a 1. Okay, parabola we have studied before. There are 2 types of parabolas you have to know about. We've got the up-down ones, but there's also the left-right ones. Okay, so when it's y equals x squared, that's going to be an up-down, a vertical parabola. And the vertex is at hk. So they keep the number by the variable, and then you change. Okay, that's going to keep things consistent. Now here, the y number is getting squared. And so that's going to make it be a right-left parabola. So if it's x equals y squared, then the parabola either goes left or right. But if it's y equals x squared, just like Algebra 1, it's either going to be going up or down. Okay, it's not a hyperbola, up or down. Okay, let's take a look at one here. Here is an equation. It's going to be a parabola. We have to complete the square, but only on one letter. And the letter we're going to complete it on is x. So y equals, let's get this in descending order here, 5x squared minus 40x plus 82. Okay, are we ready to start completing the square? Well, hang on, it's not ready yet. Remember, you have to get the 5 alone. So we are going to factor out of 5, but out of which numbers? Just the x numbers, okay? That 82, you're going to shove him way down here to the right. 82 is not in the picture. It's just these x terms. So x squared minus 8x, close your parentheses. And this is where we're going to go ahead and complete the square. So half of 8 is 4 and squared is 16. Remember, it's always plus because squaring. So how much did we just add? Well, it wasn't 16. Remember the disguise? That's actually 80. We just added 80. So what we can do to compensate is subtract 80. So now we have y equals 5, x minus 4 squared plus 2. Now, some people like to leave it the way we studied the first chapter. Some people like to take that 2 and move it to the other side. Okay, so either of these are good. This is technically standard form right here. When you look at something like this, there's a couple of things you have to be able to answer. Okay, so the first thing, which way does this parabola open? Is it up, down, or left, right? Since the x is getting squared, it's definitely up, down, and the leading or the constant here is positive, so it's going to be opening up. Hey, what does that 5 number mean? That means vertical stretch by 5. Okay, and how about the vertex? The vertex. If you like this form right here, where the numbers are next to their letters, then you're going to change. When we first studied this chapter, we changed the x but not the y. So either way you want to look at this, it's going to be a positive 4 and a positive 2. Now you're not going to have to graph anything, but you would want to look for the parabola that was 1, 2, 3, 4 to the right, 2 up, was opening up and had definitely some stretchiness to it. So it didn't go 1, 3, 5. It was multiplied by 5, vertical stretch of 5. Okay, that should probably be enough to take care of the parabola equation. There's usually one conic section equation question on the test. Okay, hyperbola. Okay, hyperbola, I'm going to put a little note here in red. The dead giveaway that you have a hyperbola equation is it has a minus sign. Okay, he has a minus sign. He's the only one that actually has the here, right here in the middle. He has a minus sign. Okay, so here's what the hyperbola looks like. Here's one that's opening up and down. Okay, they're almost like big parabolas, but there's two pieces to them. This one is going up and down, okay, along the y axis, kind of. So if the y is going up and down, then you want to get the equation that has a y first. So this equation right here goes with an up-down hyperbola. Now I know that there's a minus sign in the middle. That's how I know it's a hyperbola. And if the y is first, that means it's going up and down. Okay, over here I see another hyperbola. Now this one is going left and right. Okay, and by left and right, I mean that it's got an axis right here that's going x left and right. That means you have to use an equation that has an x going first. Notice how these guys both have the 1, just like the ellipse did, except there's a minus sign with this one. Okay, they don't usually pick hyperbola for ACT, but sometimes it'll be identify the conic shape. So if you see a minus sign, then you automatically know it's going to be a hyperbola. Okay, here's a variety of questions just to quiz you and see if you've learned what you were supposed to. Determine the graph represented by the equation. Okay, so can you just tell me what the graph is? I'm looking at this equation. I see a 1. There's an x squared, a y squared. Oh, I see a minus sign. That means that this shape is a hyperbola. Hyperbola. Let me ask you some things about it. Can you tell me the center? Tell me the center. Tell me an x and a y number. I hope you said 1, 2. Can you tell me the transverse? Transverse means which way is it going? Is it a left-right parabola along the x, or is it up-down along the y? Since the x is first, the transverse is x. And what that means is the hyperbola is going left and right. Okay, those are the things you should be able to tell just by looking at the equation. Let's look at this one over here. What shape is this? I see squared, squared, and there's a plus. And there's a number over there. If I divided by 9, give that a 1, I'd have to divide by 9, They'd all have 9s down there. This graph is a circle. This graph is a circle. Let me ask you some things you should be able to answer. What's the center of the circle? I hope you said 3, 5. X, y. Change. How about the radius of this circle? The radius would be 3. If you divided all of them by 9, the r sub y would be 3, the r sub x would be 3. So either way, the radius is 3, every which way you go. Okay, let's take a look at this next one right here. What shape is this graph? I see a 1, and I see a plus sign. So don't say hyperbola. But this one's tricky. It's not a circle. And it's not an ellipse. Are you saying ellipse? Because look carefully. X is squared, but the y is not. If only one of them is squared, parabola. And we don't usually have it in that form, so this was kind of tricky. Parabola. Okay, let's look at this next one right here. What shape is this graph? What conic section is being defined? There's x squared, y squared with a minus sign. Dead giveaway. Hyperbola. Hyperbola. Let me ask you some questions about it. What's the center? There's no numbers by the x, y. Well, then that means the center is 0, 0. How about the transverse? Okay, remember what that means? Which way is this going? Since the y is first, the transverse is y. That means that the hyperbola is going up and down. Up and down. Okay, down here, bottom left-hand corner. What shape is that? It's squared, squared. It's not a parabola. And it's plus, so it's not hyperbola. What shape is that? Question mark? Ellipse. Ellipse. Let me ask you some things. Can you tell me the center? 4, comma, -7. Can you tell me, let's do the radius, but r sub x. What's his radius? R sub x, 7. And how about r sub y? How about the radius in the y direction? 6. Knowing this stuff would be enough to find the picture if you needed to. And this last equation right here. When only one letter is squared, that is the shape of a parabola. Parabola. How about the vertex? The x number would be 2, and the y number would be -3. Change, change, since it's by its letter. Which way does this one open? Up, down, left, or right? This one's going to open up, since the x is squared. So hopefully that's enough conic section notes to get that 1 or 2 questions they put on ACT. We're going to dive in way deeper when we get to this chapter, but I wanted to make sure you had enough knowledge to get that question.